Astronomers are always listening into outer space, so imagine you're listening closely for something as quiet as a pin to drop. Bam, you hear something as loud as books slamming on a table. That's what happened in 1977. And take a look at this. This is a copy of the actual notes that this astronomer made back then. You can see he circled the moment that the sound happened, even wrote the words, wow.
In 1977, astronomers detected a strange burst of radio energy from deep space that lasted just 72 seconds, sparking decades of debate. Dubbed the wow signal for the exclamation written beside it, this transmission remains one of the most intriguing clues in the search for extraterrestrial intelligence. Nearly 50 years later, the mystery has only deepened. Recent discoveries of bizarre, repeating radio signals, some eerily resembling human speech, are reigniting speculation. From dead stars colliding to whispers from the cosmos, scientists are grappling with phenomena that defy explanation. The wow signal that started it all.
It's this big telescope is scanning the sky, and it's just collecting, like, how strong is this radio wave coming in, and what's its frequency, right? And then it was printing out just like those numbers, right? So 1, 2, 3, 4, 5, all the way up to 9, and then it's just a single digit. So after 9, they go to A. So, 2 would be twice as strong as the noise background. A would be 10 times as strong as a noise background, so 1 through 9, and then A, B, C, D, E, F, G, right? And then people would have to go through it and just look through, is there anything interesting? Is there anything interesting?
The wow signal was first picked up on August 15, 1977, by Ohio State University's Big Ear Radio Telescope. Astronomer Jerry R. Amon was poring over printed computer data when he circled a peculiar sequence of characters, 6EQUJ5. That alphanumeric string represented a sudden spike in radio intensity at a very specific frequency, 1420 MHz, which is the natural emission frequency of hydrogen. It was brief, narrowband, and powerful, leading Amon to scribble "wow" in the margins. The name stuck, and so did the mystery. Despite repeated efforts, the wow signal was never detected again. Scientists tried to replicate the results using the same equipment and later using more advanced telescopes, but the signal never reappeared. What made it so captivating was its origin. Not only was it isolated to a narrow frequency, unlikely to be produced by natural cosmic noise, but it was also close to the hydrogen line, a frequency that some scientists believe would be the logical channel for intelligent alien communication. Over time, skeptics proposed alternate explanations. Some speculated the signal came from a satellite or spacecraft, while others pointed to comets emitting hydrogen clouds as they passed through the solar system. In 2017, one researcher suggested Comet 266P Christensen might be responsible. But the idea failed to gain universal acceptance, especially because no comet could have emitted such a stable and powerful narrowband signal. The wow signal's significance lies not only in what it might have been, but also what it represents, a brief, tantalizing glimpse of the unexplained that still challenges our understanding of radio astronomy. The 2-hour mystery from dead stars.
When we talk about aliens, we talk about the search for extraterrestrial life. We kind of mean E.T., don't we? We mean something that we can talk to.
The wow signal, as it's now called, is considered to be one of the best potential radio communications from an alien life form.
In a separate and more recent cosmic mystery, a repeating radio signal that blares out every 2 hours was picked up by LOFAR, the Low Frequency Array, one of the most sensitive radio telescopes on Earth. First noticed in 2015 by astronomer Iris de Ruyter, the signal was both rhythmic and persistent, sending out pulses at precise intervals with almost mechanical precision. At first, researchers were baffled. Then they traced its origins to a binary star system involving a red dwarf and a dead star, specifically a white dwarf. The phenomenon occurs as these two stellar remnants orbit each other so closely that their magnetic fields interact violently. Each time they collide or magnetically align, they emit a strong burst of radio waves that reaches Earth in clockwork fashion. What startled astronomers most was the realization that these blasts were similar to emissions previously thought to be exclusive to much more extreme cosmic bodies like neutron stars and magnetars. This changed how scientists view binary systems. It was once believed that only highly compact, rapidly spinning neutron stars could generate such repetitive radio frequencies. Now, it appears that more ordinary celestial bodies, if one can call a dead star ordinary, can produce similar effects. The periodicity, however, still leaves many researchers uneasy. The perfect timing of the bursts doesn't resemble the chaos typical of cosmic phenomena. It seems almost too structured, too consistent. Although scientists have a working theory for this specific 2-hour burst, the implications reach further. If white dwarfs and red dwarfs can generate repeating signals like this, what other combinations in the cosmos could do the same? The human-like radio signal and long-period transients.
Because everybody was looking for aliens. For the most part, everybody's looking for a radio signal from an extraterrestrial source, and I wanted to approach this from a natural phenomenon.
This frequency, 1420 megahertz, the hydrogen line, comes from when you've zapped hydrogen, you've given it energy, and this is the frequency it screams at.
In one of the most recent and astonishing developments, a radio signal emitted from 16,000 light-years away stunned astronomers with a new twist. It appeared to match patterns similar to human speech. The source, dubbed ASKAP J1832-0911, was first detected by the Australian Square Kilometre Array Pathfinder and later confirmed by NASA's Chandra X-ray Observatory. It transmitted consistent 2-minute bursts every 44 minutes, an unprecedented cadence in known space phenomena. It belongs to a class of cosmic anomalies known as long-period transients, LPTs. These are signals that occur not in milliseconds or seconds, but in intervals of several minutes to hours, something that shouldn't happen under most known stellar models. What added to the enigma was that this particular LPT didn't just pulse, it appeared to shift in tone and pitch in ways that echoed structured communication. Some astronomers speculated that the signal could originate from a spinning neutron star whose emissions become visible only when rotated towards Earth. Others proposed it could be a magnetar, a type of dead star with intense magnetic fields. Yet neither of those theories fully explained the frequency, regularity, or the apparent voice-like rhythm of the emissions. It was as if the universe had its own Morse code and no one could decipher it. Andy Wang, one of the lead researchers, called the find, quote, unlike anything we've seen before, suggesting the signal might hint at an entirely new form of stellar behavior, or more provocatively, something else entirely. A more recent strange case.
The evidence here is certainly the strongest evidence we've ever had for life on another planet.
Not long after this discovery, another puzzling signal, ASKAP J1935+2148, joined the growing list of unexplained broadcasts from deep space. This one came with its own bizarre attributes, a mix of long, bright pulses, weaker, fast bursts, and periods of total silence. Detected by the same radio telescope system and located within the plane of the Milky Way, this source baffled researchers by behaving inconsistently across multiple observations. The prevailing theory is that it's a very slowly rotating neutron star. Neutron stars typically spin rapidly, producing quick, reliable pulses. But this object seems to defy those rules. At times, it emitted signals that corkscrewed through space like a twisting drill, suggesting complex magnetospheric activity that science has yet to explain. Its inconsistent rhythm, alternating between strong, weak, and absent signals, created what some researchers likened to a cosmic stutter. Adding to the mystery is the absence of other highly magnetic white dwarfs nearby, which complicates the white dwarf hypothesis. The characteristics don't fully align with anything known in stellar evolution. Researchers Manisha Caleb and Emil Lenk were careful to note that while the data suggests a slow-spinning neutron star, quote, we can't quite explain the signal's full behavior. The possibility remains that it's something entirely new. These discoveries keep piling up, and with each one, the line between natural and unnatural blurs a bit more, and when signals begin to behave in human-like ways, it's not hard to wonder if someone or something is behind them. Now it's time to hear from you. Do you think these strange radio signals could be the first signs of intelligent life beyond Earth? Let us know your thoughts in the comments section below.